Good morning, guys, and welcome to your second video. We're going to start by learning about outliers and then see how outliers affect one of our previous measures of center that we talked about in the last couple of days, either mean or median. So first things first, we need to know what an outlier is. So an outlier is a value or values that's far away from, or outside the set of data. So if we look at our example over here, here's where the majority of our data set is, but then over here I have this one lonely little data point, and it's really outside the rest of the data set. It's really far away from the rest of the data set. And so that guy would be an outlier. And outliers can either be bigger or smaller than your data set. So in this case, this one's bigger, but let me give you an example of where we might have an outlier that's smaller. So take our test and our quizzes, right? If we take a quiz and the majority of students make between an 80 to a 90, right? Or they're making 80s and 90s, then our class average, they're making between 80s and 90s, but then we have like one or two students who make 20s. Then those one or two students would be considered outliers and they're smaller outliers because they're smaller than and way outside where the rest of our data set is. So that's just an example. And outliers tend to skew, SKEW, they tend to skew or throw off, that's all that means, um, our data set when we're either talking about our mean or our median. So outliers affect one of those. Go ahead and take a minute to see if you can figure out which one it affects the most. So if you finished reading the problem, you would have seen that outliers skew or throw off data when finding the mean. So think about it. If the majority of students made between 80s and 90s, you would expect our average to also be between 80s and 90s, correct? Sometimes like an 85. But if we have one or two students who made a 20, that just drastically changed our mean. That drastically changed our class average. It dropped it down maybe to 70 or 65. So outliers really affect your average because of them being so outside your data set. And when we're finding average, we have to include that number and we have to add them all together and divide by how many they are. Outliers don't affect your median because all you're doing is putting them in order from least to greatest. So it would be there anyways. The number would be there anyways. And you're just finding the middle number. And usually it's not your outlier. That's the middle number. So it doesn't really affect our median. So something we need to be aware of is when outliers are present, our best measure of center is going to be our median. Okay. So let's hop over and see if we can compare mean versus median. So hikers spent the following amounts of time to complete a nature hike. You can read the numbers. We're going to find the mean, we're going to find the median, and then we're going to say whether or not there's one measure that describes the data better. So go ahead and pause the video real quick, and I want you guys to find the mean and the median. You guys can do that on your own. Go ahead and pause and do that. All right, so when finding the mean, hopefully you guys got an answer. You added them all together and you got 430, and you were supposed to divide by 8, and that should have given you an answer of 53.75. Okay, and again, if your decimal ends, if it's a terminating decimal, meaning it ends, go ahead and write the whole decimal. But if it's a repeating decimal, make sure you round to the nearest tenth. All right. And then when finding our median, you should have put all the numbers together and you would have ended up with 52 and 56 in the middle. You should have had two numbers in the middle, meaning you had to add those two numbers together and then divide by 2, and that would have given you an answer of 54. So your median is 54. So let's ask ourselves, does one measure describe the data better than the other? Well, what do you notice about these two? I notice that they're both very close to each other. We have 53.75 and we have 54. So they're 0.25 distance away from each other. So, and then when I look back up at my data set, I don't see an outlier. And so I know that my mean is not being skewed or thrown off. So in this case, both would be a good measure of center.